Kalau awak kira berapa yang masuk, berapa yang keluar tu, kalori kan, kalori yang awak makan semua tu. So itu adalah one of the energy lah. But in term of physics, we are not looking on that lah, the chemical punya energy. Okay, alright. So outline for today, we're going to see only work lah. Sebab sejam je kan. Work pun dah 1 hour. Okay, macam tu. Right, so what is work? Okay, work done by a constant force. Yes, salah. Okay, so it's defined as a product of the component of the force parallel to the displacement times the displacement of a body. This one is direct definition, ataupun lagi direct dia kata product between force and displacement of a body, basic term. Okay, so we get this equation. Okay, so sebabnya physics biasanya kita come out dengan equation dulu, then baru kita define. Daripada equation ni kita define. That's why you will notice that the equation, the definition tu adalah the equation yang kita tulis secara in sentence. Okay. Alright. So F dot D. So F dot D. So both vector, but because of the dot operation, okay, then it become produce product of a scalar product. Okay, scalar product. Okay, so a vector. Okay, so but macam mana nak cakap? So both need to parallel. Okay, sebab dia dot kan. Dot bila dia parallel yang dia akan jadi equal to 1. Okay, okay, so cos theta. Cos theta, where's the angle? So the angle is between F and D. Let's say we have D in this direction, then we have F, so this is the angle. So cos angle here is yang ni lah. Okay, so the angle is angle between F and D. It's not the direction for D, it's not the direction for F, but both kenalah parallel. So in order to parallel the D to F ataupun F bring to D, so we get this equation F cos D, ataupun mungkin kalau terbalik pun boleh, D cos theta times F. Vice versa lah. Tak kisahlah, salah satu ya. So it's a scalar quantity, so the unit is joule. Joule macam unit apa? Energy kan. But this one we still talk on work. Okay. And then kilogram meter squared as negative 2. So 1 joule. So what is 1 joule? Joule tu apa? Okay, so 1 joule. Bila kita ada 1 joule means that kan mudah kita nak explain. So kita letaklah nombor. Nak letak 7 joule. Letaklah 7 joule. Define lah 2 joule as the work done by a force of 2 Newton, which result in a displacement of 2 meter in the direction of the force. Kalau orang tanya apa maksud 2 joule tu kan. Okay, result in displacement of 1 meter. So yang ni macam ulang balik di equation je sebenarnya, alright. We also, okay, so you also can use this unit. Tak ada masalah. Boleh sebabnya Newton tu pun SI juga. So meter SI ataupun nak banyak kilogram meter squared per second squared boleh juga. Alright, so work done by a variable force F whose magnitude change is the displacement D. Okay, so for a small displacement, the force remains almost constant at F1, and work done therefore becomes F1 equal to F1 delta T. And then we can get to plot this graph. Kita dapatlah graph yang macam ni. So kecil-kecil bila kita bahagikan. So contohlah force yang berikan banyak ni, menggerakkan blok tu banyak ni. Kita bagi force lagi, then tambah lagi distance. Blok tu bergerak sini, 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 sini sampailah akhirnya delta D and dengan menggunakan that force. To find the total work done by a variable force when the displacement change from D equal to D1 to D equal to D2, we can divide the displacement into n small successive displacement. Okay. Right. So this is the displacement lah. Sikit. Then we put graph, and from here we get the equation. Okay, so F times delta D is our work done. Okay, ataupun nak tunjuk secara kalkulasnya, where we get that equation. So we get from the integration of the graph. Okay, so as the integration, so S1 to S2, so we get Fs, the area under the force displacement graph work done tu. Sekejap siapa ni? Okay. Alright. Yes, sekejap. Okay. Okay, so the area under the force displacement graph. So that is your work equal to the area. So application of works equation. So work done by a horizontal force on an object. So let's see how we can form the equation for the work done for this case. We have force, okay, in this direction, right? To the right. Okay, so we have force in this direction, and this force caused that block move from this point up to this point. So we have a displacement here. Okay, so dia akan ada work done lah, sebab that force menyebabkan ada displacement. Then the work done is there. So FD cos theta, and for this case angle equal to 0 degrees, so it will experience maximum work done. Right, so for this case work done by a vertical force. For this case, okay, kita ada force in this direction. Okay, but you are moving in this direction, but the block move in this direction. Okay, so what happened? What happened is theta angle equal to 90 degrees. So when 90 degree, when we substitute in this cos 90, okay, so we get 0. So no work done. So even menggerakkan dia dalam bentuk force yang begini, tapi dia equal to 0. Macam tak buat kerja lah. Okay. So work done by horizontal forces. Contoh, we have more than one force, both horizontal. Then what happened? We can simply add up that two forces saja, sebab total work done kita adalah macam tadi dia kata adalah daripada force, okay, force yang act on that block, means that your F net, Okay, so your work done, you need to consider the F net, not the force alone. Okay, you need to consider the total force act on that object. Okay, so work done by a force F and frictional force on an object. Contoh. We have this kind of force. So again kita kena ambil dia F net. So F net dia adalah apa? So this is the F net. F net dia F cos theta minus frictional force equal to M A. Work done on an object is 0 when F equal to 0 or D equal to 0. So either one lah ya. Okay, so contoh macam ni. Okay, so work done equal to 0 on spacecraft. Sebab apa? Constant velocity. So bila constant velocity expression equal to 0, force equal to 0, then the work done, no work done here. Nah, macam ini pula, it give force, diberikan force, but nothing happen. Tak ada apa yang bergerak kat sini. Okay, so the dinding masih kat situ. So no distance. So equal to 0, the work done. And then for this case, work done and then constant speed in a circle, car moving, then F equal to 0. Even the uh, moving of the cars, we give a value of a distance or displacement, but it still don't have a work done. Alright, so sign for work. Again, okay, so we have agreed that F dot S or F dot X is the dot product, means that it is scalar. But the sign is, mana dapat sign dia? Sign is just to explain that whether dia perlukan work ataupun dia yang memberikan work kepada that system. Let's say we have for case yang the angle in between 0 to 90 degree. Okay, so it will have a positive work done. Okay, positive work done. But for case the 90 to 180, okay, so the work done is negative to show that work done by the system where energy is transferred. Okay. All right, now we go to example. Example, you push your physics reference book 1.5 meter along a horizontal table with a horizontal force of 5 Newton. The frictional force is 1.6 Newton. Okay, so calculate the work done by the 5 Newton force. Push your physics reference book. Okay. 5 Newton. Okay, so the frictional force is 1.6. So the work done by the 5 Newton force. Okay, so this is the free body diagram and this is the distance lah, 1.5 meter. Work done by the 5 Newton force. Okay, so soalan ni dia nak fokus on work done by this force. So kita akan ambil that force and times the distance terus. Macam tu je. Okay, simple And then B, the work done by the frictional force. Okay, so kita akan ambil yang frictional force times dengan the displacement yang dia make tu. Okay, so the value negative since cos 180. And then dia nak apa? Total work done on the book. Then we need to total up those two forces. Okay, or those kita dah kira salah satu tadi. Total work done dia ataupun we can use this F net saja. Sebab biasanya kalau dia tanya work done on the book, kita memang kena ambil yang total work done. Tak boleh seketul-ketul lah. Macam tadi jadi seketul-ketul tu sebab kita apa? Sebab kita ambil dia satu-satu kan. Dia tanya kan, dia nak uji awak on satu-satu tu. So buatlah satu-satu dulu. Macam tu. Okay. Alright. And then a box of example. Alright. So next example is on incline plane. So horizontal 25 degree, it is pulled by a horizontal force. Okay, so ada horizontal force here. Tengok gambar dia macam mana. Okay, horizontal force. Macam tu. Sebab dia kata dia incline, then horizontal force in that direction. So kita resolve. So free body diagram lagi. Normal force W. Okay, frictional force. Okay. Alright. So this is the free body diagram. So sekarang kita tengok soalan dia nak apa. Work done on the box by the force F. Kita tengok. Ya, so Fx lah. Dah masuk ni. Masuk ni. Haziq pernah masuk tadi. Okay. So, F tu, dia kata by F kan. Tapi F mana yang parallel to D? Macam tu. Itu persoalan dia. So, only yang parallel dengan D yang kita akan consider in our calculation. So, Fx cos 25 degree 3.8. Okay, ataupun kalau betul kita nak ambil that force, sekejap. Manakah? Ataupun kita nak ambil force ni kan. So ni make 25 degree kan. So F kan. So kita boleh tulis juga F cos 25 FD. Ya Allah, kenapa suka jadi macam ni ya. FD, ya Allah. FD cos 25 pun boleh. Cuma yang ni sebab kita dah biasa kita resolve the component, so that we take yang parallel dengan D pun dibenarkan juga. So it's up to you lah. Which method you want to use. Yang awak dah biasa. Okay. And then second one dia kata gravitational force. Again, bila kata gravitational force, tengok mana gravitational yang parallel dengan dia juga. Okay, so yang parallel dengan dia adalah mg sin 25 degree. So we get this value. Nanti tanya apa? Nombor ke? Ya. Tadi ada hai. Betul. Ya betul lah. Betul. Put down on the box by the reaction force, which is N lah, and then total work done. Frictional force, okay. Okay. So reaction force is your normal. So normal make how many degree to your displacement? Sekarang ni 90 degree. So substitute 90 degree and what happened? Your work done will equal to 0. Then frictional force. Okay, frictional force memang sekejap lah. Okay. So equal to 0 and then frictional force pula. Work done by frictional force. So yang parallel dengan dia memang mu KN dah. Angle, ambil angle. Displacement arah sini and then your frictional force in this direction. So you need to take 180 degree. Okay. Alright. So negative ni 3 to 3 lah. And then you need to find the net work done. So masukkanlah semua yang awak kira tadi. So mana yang plus, mana yang minus, letakkan minus and you get the value of your total work done is 223 joule. And then by equation of work for net force, find acceleration. Tak ada masalah. So kita equatekan saja MA D. D is the displacement. This is your total work done. Find your acceleration. And then dia suruh cari berapa final velocity so masukkanlah dalam equation motion, equation of linear motion, then you may get your velocity. Alright, then another example. Sebab untuk ni memang mudah je. Okay, so dia punya teori is just work done equal to F dot D where FD equal to FD cos theta tu je. Okay, ilmu dia hari ni kita belajar selama sejam ni. Okay, tapi kita ada walaupun itu saja ilmu dia, so it can come out with different type of question. So contoh soalan ni pun boleh juga. So a horizontal force F is applied to a 2 kg radio control car as it moves along a straight track. The force varies with the displacement of the car as shown in figure 5.6. Okay. Alright, so calculate the work done by the force F when the car moves from 0 to 7 meter. So ini adalah equation graph for F versus S. Okay, so force varies with the displacement of the car as shown in figure. Okay, alright. So soalan dia. Area under the graph Fs. Kan? Sebab tadi kita belajar area under the graph is the work done, and again kita consider displacement and not the distance. So you need to consider the negative lah. The negative kena consider, and the value of the work done equal to 18 joule. Okay. Alright. And then this one exercise. Masuk sikit lah. Nampaknya ada masa lagi. Saya rasa kita masuk sikit lah energy conservation. Okay. Alright. Okay. So energy and conservation of energy. Okay, so now kita tengok sikit kita tengok energy sikit. Apa ni? Dalam 10 minit Alright, so energy. So what is energy? So how it relates to work? Why the unit is the same? Okay, so energy is the can be defined as the system ability to do work, scalar quantity, and it is scalar quantity. Work pun scalar quantity juga, joule ya. So bila kata scalar quantity, we don't need to consider the direction. but it's just whether we we take the energy ataupun we release the energy. Okay. Alright, so forms of energy. So here is some form of energy. So we have chemical energy, we have electrical energy, we have heat, and we have internal. Okay. So chemical energy is energy released when chemical bonds between atoms and molecules are broken. So this energy is kita tak nampak lah. Okay, so kita tak nampak. Dia berlaku secara kimia. Okay, dalam chemical bond. But you can calculate kan. Okay, macam apa yang awak kira tu, kilojoule tu. Yang tu lah yang awak kira. Kalau dalam kimia awak kira lah. Macam apa tu. And then electrical energy that is associated with the flow of electrical charge. Okay, so that one become the electrical energy. So this is a form of energy. Contoh from the chemical, okay, kita daripada bateri hasilkan elektrik, lampu. So daripada chemical energy dia akan transform pergi electrical energy, transform pergi heat energy, macam tu lah. Okay, sebab energy sifat dia boleh transform tapi cannot be destroy. So when we talk about internal energy, it's about total kinetic and potential energy of atoms or molecules within a body. Okay, yang berlaku dalam body tu saja. Okay. Is dia dalam satu closed system lah. Okay, and then we have another forms of energy. Okay, another form of energy. Alright, so nuclear. Okay, so we have nuclear energy, we have mass. Okay, so mass memang yang ni lah. Yang apa, Einstein. Okay, which is about the nucleus. Bila nucleus tu ada mass juga kan. So proton and electron number semua tu. So the difference of the mass we contribute to the mass energy. Okay. And then radiant heat energy associated with the infrared radiation. So that one consider as energy juga. So basically is something yang apa tadi dia kata yang dia define sebagai yang work done kan. Okay, so basically dia yang memberi impact lah. So force tu tak sekuat macam energy. So force is something yang untuk menyebabkan berlakunya tapi daripada force tu lah berlakunya energy. Macam tu. Okay. But force and energy is not the same lah. Force tu rendah sikit lah. Tapi daripada force tu lah berlakunya energy. Okay. Right. And then sound energy is one of the energy juga. Sebab apa? The vibration. Okay. Sound is about the vibration. Then menghasilkan suatu energy juga. Okay. And then we have mechanical energy, kinetic gravitational potential, which is energy associated with the motion of a body. And for your syllabus in this chapter, we will only consider the mechanical energy, which is kinetic, gravitational potential, or the other related potential lah. Elastic potential. Only these three energy that we will consider for this chapter. So let's introduce. I want to introduce to you sempat kot kinetic energy sikit. Okay. It's defined as the energy of a body due to its motion. So half mv squared. So maksudnya sekarang ni kalau dia kata at rest je terus tak ada dah, tak wujud dah kinetic energy ni. Okay, sebab dia kata due to its motion must have velocity. If no velocity, then your kinetic energy equal to 0. Then kena check lah. Kalau kinetic energy 0, apa energy yang dia ada? Mesti kena ada juga sebab energy cannot be destroyed. Okay, kalau dia duduk saja tu, dia ada energy apa? Mesti ada, mesti kena ada. Macam tu Okay. So consider a block with mass m moving along the horizontal surface under the action of a constant net force undergoes a displacement. Okay, so contoh we have this case. Then ni nak cerita pasal work kinetic energy theorem work kinetic energy theorem. So dia kata, and first dia moving along horizontal surface, so F net equal to MA. So equation, motion, so we get that equation. And from here, from this equation, so your F net, okay, akan equal to your half mv squared minus half mu squared, where we can have the kinetic energy for final and we can have the kinetic energy for the initial. And we equatekan dengan apa ni sebenarnya? Work done. So work done equal to kinetic final energy minus initial kinetic kinetic energy initial. Okay. So this theorem is to describe that work kinetic energy theorem. Okay, yang mana Kf minus Ki, the change, okay, change, basically the change lah, change of the kinetic energy we equal to your work done net, yeah. Okay, so we have this example. Alright, so a stationary object of mass 3 kilogram is pulled upwards. So again, macam saya cakap, your free body diagram also apply to this chapter juga sebab dia memang cross related dengan your punya force since your work done. How to find your work done? Work done is equal to F. So awak tak boleh lari dari your punya free body diagram. So to solve this, you still need to have your free body diagram. If not, then you cannot, because the work done, we consider the F net, not the F alone. Macam saya cakap ya, not only the force applied. You need to consider all the forces act on that object. For that, you still need to know how to draw the free body diagram. You need to understand that you should start with free body diagram juga. Okay, so bila awak dah buat free body diagram, bagi soalan apa pun settle. Okay, so F net equal to 20.6 Newton. Okay, so mention here you need to apply the work kinetic energy theorem. Then you need to apply the one that we have learned just now, which is the work done equal to the change of the kinetic energy. So mention here that macam mana dia kata tadi? Upward, pull upward. So initially that block 0. So initial kinetic energy equal to 0. Then we can solve the velocity using this equation, using this theorem. Okay, if not mentioning that you need to use this theorem, then you may use the other way. Okay, tapi sebenarnya kita buat the theorem is to mudahkan hidup you lah. So suppose kalau case yang begini involve energy, then you need to do your work kinetic energy theorem. Okay, I think we can have another one example. Masih ada masa lagi. Okay, so a block of mass 2 kilograms slides 0.75 meter down. So this is displacement, mass, and then that is the angle of your inclined plane. If the block starts from rest, calculate its final speed.
Madam,
Yeah?
tak nampak sikit dia punya diagram tu. Macam ke bawah sangat.
Oh ya ke? Okay, okay. Macam mana? Tu tak ada apa pun. Okay. Right, so again, always start with free body diagram. Okay, then lepas tu dia nak tanya apa pun kita dah boleh jawab. Tapi dia tanya apa sebenarnya? Block saya calculate of its final speed. Okay, final speed. So dia kata start from rest. So use your work energy theorem. Before that, you need to find your F net first. Okay, so that you can substitute in this equation. So your F net time dengan S already given half mv squared. So you find your final speed. Kita lagi satu example rupanya. Okay, so boleh ikut macam itulah. And then another one example. Okay, so 2 kilogram move along x-axis and is acted on by a force F. Shows how F varies with distance traveled. The speed of the object s equal to 0 is 10 meter per second. So again, for this case, it given graph of F against displacement. Okay, so determine the speed of the object at s equal to 10 meter. Okay, so s equal to 10 meter lah. Dia nak speed of the object at s equal to 10 meter. So this one is your displacement lah. Alright, so we can find it. Macam mana dia buat? Dia kata dia nak work done speed. Okay, dia nak speed dah. Speed of the object. So, since kita under this topic, then the speed kita akan cari menggunakan work and kinetic energy theorem lah. Thus, we get this equation. So, work done, kita dah ada. So, substitute saja. Half mv squared and you may find. Initial biasa kosong tapi this time kita ada. So, janganlah bila kata initial ataupun final tu awak terus zero je. So, kena check balik. So, ada tak initial velocity dia? So, berapa? Tadi already mentioned them. That the initial velocity is 10 meter per second. Then you need to substitute that value lah. And find your final velocity. Okay. Alright. And then B. Kinetic energy of the object at s equal to 6 meter. Kinetic energy 6 meter, setakat 6 meter saja, tak apa. So kita ambil je lah work done yang setakat 6 meter, then equatekan, kan? Dapatlah kinetic energy dia. Macam tu. Tadi dia nak velocity, so kita buka lah equation tu, half mv squared. This time dia nak kinetic energy, so tak payah buka lah equation tu. Biarkan dia dalam kinetic energy macam ni. Work done ni kenapa lain? Work done ni is sampai 6 saja. 6 ni, so this is your work done sampai 6 meter tu. Okay, and your kinetic energy is this value. Now dah sampai exercise and ada lagi sebenarnya potential energy, tapi tak apalah, yang ni kita akan sambung esok. Okay, so today apa yang kita belajar simple je, kita belajar work done. Okay, work done equal to apa, F dot D. Okay, so F D cos theta means that the force and the displacement kena parallel. Kalau tak parallel, kita parallelkan dia by using your cos theta tu. Tapi parallelkan sekali je lah. Jangan banyak-banyak kali parallelkan dia tu. Okay. Lagi apa kita belajar hari ni? Work kinetic energy theorem, where work done we may equatekan dengan the change of the kinetic energy. So Kf minus K initial. So esok kita akan tengok yang lain pula, work energy theorem yang lain. So ambil nafas dulu. Tengok dulu apa yang kita dah belajar hari ni. Go through balik sebab esok kita akan pergi yang lebih mencabar lagi. Okay, boleh kelas? Any question?
Boleh.
Boleh
Alright,
madam, boleh,
good.
boleh.
Boleh madam.
Alright, good. Okay, so I hope that awak boleh follow lah saya punya cara ni. Okay, kalau laju bagi tahu, nanti saya akan cubalah. Tapi inilah speed yang paling perlahan lah, sebabnya memang kita kena habiskan satu chapter satu minggu. So try to follow. Saya pun dah try simplify everything so that awak boleh faham. Okay, at least understand the concept. Since once you understand the concept, you can apply it into many problem. Apa saja problem yang awak dapat, then awak boleh selesaikan. Okay, I think that's all for today's class. Thanks for your attention. That's all. Thank you, class. Assalamualaikum.
Thank you, madam.
Bye.
Madam.
Thank you madam.
Thank you, madam.
Bye. Welcome. Bye. Welcome.
Thank you, madam.
Thank you, madam.
Welcome.
Thank you,
Bye.
madam.
Alright.
Thank you,
welcome.
madam.
Welcome. Bye.
Bye-bye, madam.
Bye.
Thank you, madam.
Welcome. Bye.
Thank you, madam.
Welcome. Bye.